We are going to start the logarithms unit today, or I guess with this lesson. The thing is, you need to know how to take care of inverse of a function from the grade 11 functions course so that we can go on. So as you can see up here in the description of what I'm doing, this is inverse part 1, where I do a little review on linear and quadratic functions with respect to the inverse. Then what I'm going to do is I'm going to take care of exponential and logarithmic functions in a second lesson. So this is hopefully a review, and I'm going to assume kind of that it's not, and lead you through this, but much quicker than it would be done in grade 11. So the first thing is, there's this thing that I'll describe for you. I'll show you what it is after we get a couple of graphs down. It's called the inverse of a function, and f at x is your regular function, and we've dealt with that quite a bit, both in grade 11 likely, but definitely in grade 12 in the polynomial functions unit, even the rational functions unit. It's a really typical way of describing a function instead of the y equals. The thing is, once you pull off finding the equation of the inverse, which we're going to do in like a second area of this particular note, what we're going to do is we're going to find f inverse, and there's a notation for f inverse, and it looks like it uses an exponent, and I guess you could call this in the exponent position, but this says f inverse at x. So that little -1 that's plopped up on the f that wasn't there originally indicates inverse. So you don't have to write all that down, and you can just use this notation. It says here that f inverse is some function that has been reflected in the line y equals x, and I will show you that in a bit. What we're going to do is go through 5 examples. Sorry, 4, can't count. 2 lines, and I can tell these are lines because they're both y equals mx plus b. Here it is, y equals m as a fraction, x plus b. And then we're going through 2 quadratics, and I've picked these fairly carefully. What you do is you graph the original function, you find a few coordinates of that function, and then you switch the x and y values. You don't touch the signs. And then you graph a new set of points, and then you can connect them, and it becomes the inverse. So we're going to go through that step, and we're going to go through it with this particular example. So I'm going to plop it on this graph paper, and we're going to proceed to do that. So the first thing I want to do is draw the x and y axis, and I don't know exactly where this is going to end up, so I'm going to centrally locate it. This is a line. So I don't want to think too hard about where it's located like I would with a parabola or something a little more specific. But if I put the y equals mx plus b underneath this, you should be able to figure out that m, which is slope, which is also rise over run, in this case, is -2. And more specifically, -2 over 1, so that we have a rise and we have a run. The next thing you should be able to figure out is that b is 5. And b is your starting spot. So I'm going to do all my originals in red, and then I'm going to do all my inverses in blue. So if I find 1, 2, 3, 4, 5, that I can put a dot here. And then I can rise -2, so 1, 2, and run always to the right. And I can do that a few times. Down 2 over 1, down 2 over 1, until I get the general shape of this line. Now I'm going to connect them with my ruler maker. And just because I said to you that I was going to do this in red, I am going to turn that into a red line. And for good form, lines go on forever, so I can put arrows on the end. So if I go back to the original slide, it says graph f at x, and I've done that. The next thing we have to do is find a few coordinates on f at x. So I am just going to list a few coordinates. Really, all you need for a line is 2, and then you can slap a line between them. But this one is 1, 2, 3, 4, 5, 0, 5. No surprise, because that was the y-intercept. The one next to it is 1, 1, 2, 3. The one next to it is 1, 2, 1. And just for good measure, let me get one that's got some negatives in it. 1, 2, 3, negative 1. So you don't have to do tons, you just have to do some. So all of those things are my f at x points. Next thing we do is we switch the x and y values, but you don't touch the signs. So that means if a 5 is a negative 5, then it stays a negative 5. So I'm going to do these ones in blue. And you literally take this list of points and just reverse them. So this 0, 5 becomes 5, 0. The 1, 3 becomes 3, 1. The 2, 1 becomes 1, 2. And 3, negative 1 becomes negative 1, 3. And I have to put those dots on this picture. And then we'll have f inverse at x. 1, 2, 3, 4, 5, 0, 1, 2, 3, 1, 1 over 2 up, negative 1 over 1, 2, 3 up. And if I connect them with a line, and turn it blue, I will have the inverse. Arrows on the end. So if I go back to the original, what I can do is I can put its label on it. And I can put y equals negative 2x plus 5. I'm going to write f at x equals negative 2x plus 5. Not that it matters one bit. It means also that I should have a label for this one. So this one will be f inverse at x equals something, but I'm not sure what that something is. I will come back and do that in a minute. What I want to draw your attention to is the picture representation of what the inverse is. And it's really nice that I have the smartboard technology to pull this off. I need the line y equals x. That, from grade 11, is the truly diagonal line through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. And if I glue all this together, and I rotate it so that my green dashed line, my y equals x, is on the straight up and down, hopefully you will see that this red part is reflected onto this blue part, and this red part is reflected onto this blue part over that line. And all that is what a function is. Sorry, what an inverse is. You can tell I'm tired. I'm just going to add that label in. So if I ever ask you to graph the inverse and the original, I'll put that line in. You may see it on your page just to check your reflection ability. Okay, now let's work on this equation. Now I've got a brand new set of steps for that, which is to switch the x's and y's. So this is how to find the equation of the inverse. Switch the x's and y's and then solve for y. So I've got my original equation sitting right here. And step 1 is to switch the x's and y's. So this y turns into an x. This x turns into a y. That would happen in every spot. And then you solve for y. So that means you're going to try to get the y all by itself on one side of the equal sign. And all by itself implies that it's positive. So one of the things we could do is to take this negative 2y across the equal sign and change its operation. I'm going to leave the 5 behind, and then the x will come across and change operations. Divide by 2, divide by 2. Here's something very important. Y is equal to 5 minus x. All of it was there, and then we divide by 2. So this 5 minus x all over 2, that is what we stick here. So that also means that I should sum up all this work by saying I just found the inverse equation. So I use the inverse notation. And there we go. What I want to make sure we do is that we do at least one more line, and I've picked one that isn't so pretty because I'm not convinced that everybody will know how to do the inverse equation when your m is a fraction. So I'm going to take this here, and we're going to go through all the same steps. So the first thing I want to do is I want to draw my x and my y-axis and label them. So there's x, there's y, there's the labels. I like to write down my criteria, meaning I like to write down that m is negative 5 over 3 and b is negative 4. And I'm going to need some more space for this guy because I see right now that if I'm at negative 4, I will be expected to go down 5 more and then write 3. 1, 2, 3, 4, 5, 1, 2, 3. Now that also implies that I can do 1, 2, 3, 4, 5 up and negative 3, which is the opposite direction. So I could put more dots on there if I was a little creative. There we go. And red. And also, this line goes on forever. Okay, so let's graph the inverse. It means that I need to list a few of these points. So I've got 0, negative 4. And this one is 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 over in the positive direction, down 9. And then the other one, just for good measure, is 1, 2, negative 3, 1. So when I go to find the points on the inverse that I'll be able to use to graph, this one will flip and turn into negative 4, 0. So you literally toss these around, reverse them. Negative 9, 3, 1, negative 3. So now I'm going to try to put them on here. So 1, 2, 3, negative 4, 0. Negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, 1, 2, 3. And then 1 over 1, 2, 3 this way. And if I connect those ones and turn them blue, that will be a really good picture of the inverse. And I'll need a label for that, which we'll get to in a sec. Now at any time, you can put down the line y equals x. And extend it as long as you choose. If it goes on the picture, it is required to have a label on it. And then I'm just going to turn my head and check that this red reflects properly onto this blue, and this blue reflects onto this red, or vice versa. So now I'm going to find the equation of the inverse. So the steps again are switch the x's and y's, solve for y. So the first thing I'm going to do is write down the original equation again. Then I'm going to switch the x's. Oh, that's bad. You can't make them disappear. I'm going to switch the x's and y's. So this y turns into an x. Every x turns into a y. And I'm not happy with a negative y, so again, if I was, I'd leave it behind. In this case, I'm going to put it over here as a positive. And unfortunately, my x will be negative and my 4 will be negative, so it doesn't matter what order I put those in as long as they stay negative. So here's what you can do. This says times 5 divided by 3. So for me to get rid of this, my first step, I'm going to say will be to reverse divided by 3, in which case I'm going to times by 3. So that's negative 3x minus 12. Divide by 5 to reverse that. Divide by 5 to reverse that. We'll be leaving y by itself, and it'll be all over 5. And then I can dig out the blue pen to say, I am done. I just found the inverse. And then I can take negative 3x minus 12 over 5 and make sure the label goes on here. Okay, so I am having a bit of a hand cramp, so before I start writing madly about this one, I will put it here and then I'll take my little pause. Just for the record, this is not a line. Alright, hand cramp over, no excuses. Okay, so I need to remind you about how to transform graphs from grade 11. I do hope you know this is a quadratic, meaning this is a parabola. And I hope you know that the parabola's vertex is -1, -3. So it's this number, change the sign, this number, leave it alone. So that is one of the points. Normally, what I would do is I would use the step pattern, and this is not really a list of points that you can use for the f at x rearrangement, but we would have to move 1, 1 from there, 2, 4, 3, 9, both in the positive and negative direction to get this parabola put on the grid. But that is if this 2 isn't there. But because the 2 is there, that means this is vertically stretched, and vertical is on the y, so we have to take all those numbers and we have to times them by 2 to get a new set of numbers. So I hate to squish it in here, but that means 1, 2, 2, 8, 3, 18. So I've had to double those, and there is a reason I haven't put the brackets around all of these, and I'll show you that in a second. So if you know the movements to make for a regular parabola, you should be able to get this down on the grid. And because I have no preconceived notions about what the inverse is going to look like, which is going to go on the same grid, I have those, and I'm putting this fairly central. So as I said, the vertex is -1, -3, so that's -1, -1, 2, 3. And then from there, normally I'd move 1, 1, 2, 1, 2, 3, 4, 3, 9, and then I do it all again on the other side. So 1, 1, 2, 4, 3, 9. The problem is that stretch. Now this one isn't flipped, but it certainly is stretched because it's twice the height it usually is. So that means instead of going 1, 1, I'm going to go 1, 2 from the vertex. 2, 1, 2, 3, 4, 5, 6, 7, 8. And if I had space, I'd go 3, 18, which I don't. You might. 1, 2, starting from the vertex again, 2, 1, 2, 3, 4, 5, 6, 7, 8. It should end up across from this one, which is why I counted, just to double check, and then 3, 18. So if we connect these dots, we'll have the original f at x parabola. Oh, bad. Oh, well. So now I need to generate the actual f at x points, because as you can see, 1, 2 has nothing at it. So that's why I didn't put the brackets around it. So I know for sure that one of the points is -1, -3. That's my vertex. This one is 0 across, 1 down. This one is -2, -1. This one is 1, 1, 2, 3, 4, 5. And this one is 1, 2, -3, 1, 2, 3, 4, 5. So now I get to take those guys and I get to do the same thing as I did with a line. It doesn't matter what kind of picture you have, you do the same thing. You just flop these guys over. And then we're going to have to graph these. Connect them and we will have the inverse of this parabola. So -3, 1, 2, 3, -1. -1, 0. -1, -2. 0, 0. 1, 2, 3, 4, 5. 1. Still at 5. 1, 2, 3. Now, just for the record, this is not a function, because it would not pass the vertical line test, and my vertex is a little bit pointier than I want it to be. But that is the f inverse at x. And if I glue all this together, after I put down the line y equals x, so there's my line. Glue it all together. Hopefully it's all stuck. And if I rotate this so that my line y equals x is on the up and down, you will hopefully see that you've got a little heart here. It's upside down. But this blue and this red are reflected on each other. This blue and this red are reflected on each other. This blue and this red are reflected on each other. So that reflection, that is actually what an inverse is, totally works out graphically. So you can visualize this. So that, if you know how to transform your functions, in this case it's a quadratic, if you know how to do that, maybe this is the easy part, and we're going to have to maybe struggle, or not, depending on you, to find the equation of the inverse. So because that is there, I'm going to write it down here and then drag it down. And there we go. And follow those steps. The steps never change. Step 1, switch all the y's into x's and all the x's into y's. Try to get the y by itself. Well, this quantity of y is already positive, so I'm going to leave it over here. I'm going to take this subtract 3 and I'm going to add it on the left. The next step is I am going to divide both sides by this 2. So x plus 3 over 2. equals, and we'll have y plus 1 squared. Now we have to take off this little 2. And to take off that little 2, that exponent 2, your job is to square root. Equals the y plus 1. Bear with me for a second. So then we have x plus 3 over 2. Notice how that whole thing is under a giant square root sign. Then subtract the 1, we'll leave the y by itself. So in the end, it looks like, although it's not 100% correct, it looks like the inverse equation is all of this. But that's not right. And the reason it's not right is because somewhere in grade 11, you should have been told that the square root function is a one-armed parabola going sideways because your grade 11 course was a function course. So this is a two-armed parabola going sideways. So how do you account for the double arm? And the answer to that goes back to polynomial functions way, way back. And I'm going to draw attention to this with purple. When you take off a 2, you are required a plus minus sign. So the plus sign is the upper arm, and the minus sign is the lower arm. And then I can fill this in on my graph so everything's complete. Just managed to squish that in. And there we go. So we have one more to take care of, just to practice our transformations, and it's this one, still a quadratic. So let me do the little draggy thing, and we'll go through this. So step 1 for me, when I recognize that it's a quadratic, is I find the vertex. So in this case, it's +3, +4. And then normally, I would move 1, 1, 2, then 4, 3, then 9, 4, then 16. So square each of these. But I've got this -1/2. So we have to take all the y values, so that list right there, and times them by -1/2. And if you prefer decimals, that's totally okay. I am not going to go there. So 1, 2, 3, 1 times -1/2 is -1/2. 4 times -1/2 is -2. 9 times -1/2 is -4.5, or -9/2. So let's see how good a job I can do graphing those points. So point number 1 is my vertex. 1, 2, 3, 1, 2, 3, 4. Then from there, I move 1, -1/2. From there again, 2, -2. From there again, 3, -1, 2, 3, 4.5. And then I'm going to do the other side. 1, -1/2. From there again, 2, -2. From there again, 3, -4.5. And bam! We actually have a vertex that is, a parabola that has been moved 3 units to the right, 4 units up. It's flipped, and it's vertically compressed by 1/2. So this is like somebody took a hamburger and squished it down to half its size on the up and down, so you can fit it in your mouth. So now I'm going to list my points. And I can list as many or as few as I want to get the general idea of this. So I'm definitely going to pick that guy. It's the most important one on the entire curve. Maybe you don't want this one. Maybe you don't want this one because they're halvesies. I definitely should pick that. If you don't pick that one, that's looking a gift and not doing it properly. So 1, 2, 3, 4, 5, 2. And I don't have to do any more. I think I can make my sideways parabola with that. But I need to flop them around first. So this is our inverse list. So 4, 3, 2, 1, 5, 2. Just for kicks, let's do one more. This one is 0, negative a half. This one, just for fun, 1, 2, 3, 4, 5, 6, negative a half. So it depends on how good you are at visualizing the pattern. I can't tell you how many dots you need. I just need to make sure that it's reflected properly. 1, 2, 3, 4, 1, 2, 3. It can land on itself. It doesn't there. 1, 2, 1. 1, 2, 3, 4, 5. 2. Did you see my mistake? Oh my goodness. I can't talk and do this at the same time. I didn't actually flip them around. Whew, glad I caught that. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5. Negative a half, 0. Negative a half, 1, 2, 3, 4, 5, 6. Wow, I'm being careless tonight. And then look at these. So this is the vertex. Then you know there's a dot right there because it's a half off. And there's a dot there. So you can fake some of this if you want. Okay, not great. You can tell my hand's cramping. Also, my brain. I hope you were yelling at me in your head that way. Okay, that's terrible, but I really do have a massive hand cramp. If I turn my head sideways, which of course you can't see me doing, this would reflect properly. Here is our f at x label. And I will have to determine my f inverse at x label. I know that it's going to have a plus minus root in it. So I'm going to save myself one line this time. I know this means y. It's sitting right there. I'm going to go straight to the flopping x's and y's. Just so you know, I flopped x's and y's here, except for that one giant mistake. That's why you have to flop x's and y's here. This is literally the letters. These are the position of the numbers. So this time, my quantity for y is negative. It has a negative in front of that whole batch of stuff, as opposed to the last one we did, where it was positive, so I left it behind. So with this one, just because I really like positive y's, I'm going to take the negative 1/2 blah 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 and put it here as a positive 1/2 blah blah blah. Totally not technical math speak. Take the x over, subtract it. So this is a divided by 2. So I'm going to times by 2 times by 2. And if I times by 2 over here, that is 8 minus 2x. If I times by 2 over here, I'll have 1 bracket y minus 3 squared. I'm not putting the 1 down because I'm lazy and I don't actually want to show the division with a 1. Here's that little 2. That little 2 means put on a square root sign. But in addition to the square root sign, your job is to remember the big plus minus that goes in front. And finally, I'm going to save myself one line of work for this too. I will need to take the subtract 3, and after the root I will have to add 3, and that's going to leave me with y all by itself, so I can call that f inverse at x. So plus minus root plus minus root 8 minus 2x plus 3. 8 minus 2x, dangle the plus 3. The end. So those are your steps, remembering what you were supposed to do from grade 11 with respect to inverses on quadratics, which you spent a ton of time in grade 11 learning about, and a little bit of grade 10, and then also lines or linear functions. So what we're going to be doing is these steps right here and these steps right here to teach you about this brand new topic, which is called, let me move this down a little bit. Let me put this on full page. Introduction to logarithms, but there was no way I was going to leave you with your memory for inverse of a function, because that's really what logarithms is. So I am done this note, hand cramp and all, and I'll be back with part 2 that introduces you to actual logarithms as opposed to just warning you. Take care.